the atmospheric response to April 2024 solar eclipse using a network of low-cost GNSS receivers. And this presentation would be very similar to the one I gave at the last URSI meeting. And for those who've been present, apologize for just repeating. But I hope those who couldn't attend this meeting will be able to learn something new from that. Now, what were or are still the goals of the project? It has not been finished, but the eclipse has passed. So we want to study atmospheric response of the eclipse over our region where our university is located. Our province is New Brunswick, and we also wanted to improve the regional description. If you remember, Olu showing the network like a global map of GNSS instruments. Uh, northern Northern America is very well covered, but mostly US territory. Canada is also suffering from lack of this type of instruments, especially if it goes higher up north. And but not only so, we wanted also to spread the word about GNSS technology across schools in the province and establish collaboration with provincial schools and encourage students to take STEM, science, technology, and math disciplines, and using this sort of instrumentation. And obviously advance their knowledge, students' knowledge about Spain science, technology in the space sector in Canada. Well, the objectives of the project was to install 20 GNSS receivers, low-cost GNSS receivers across the province in New Brunswick. We've been collaborating with high schools primarily, but a few other institutions were also involved, including universities and such. So the task was to obviously install those receivers and to establish a baseline before the eclipse happens, and produce atmospheric products like regional total electron content and probably perhaps scintillation maps that didn't happen, but I can talk about that after why. And obviously monitor the eclipse event and compare it to the baseline. And a public outreach was and here actually you can see a map of originally planned stations and how the eclipse was going through the province. The middle of the province of our territory was just under full totality of the eclipse. A little bit about the bill of material or the instrument itself. Here you can see as a whole the price range for the equipment we used, and compared to some scientific grade receivers, it's much less, as you can realize easily. And on this slide, you see it's a transparent enclosure with a transparent top lid, so people can see what's inside. And it consists of a GNSS receiver itself. In this case, it's a U-Blox F9P receiver. It's it is in the top, sorry, in the bottom right side of the enclosure. And the data logger is, in this case, it's an Orange Pi. It's equivalent of a Raspberry Pi, a mini computer, single board computer. And yes, a part of our, let's say, instrument was a cell modem that we wanted to have the data in real time fed back to the university, to our server, which is unfortunately, or let's say, one of the most expensive part of the system. So we can significantly reduce it the overall price if we use internet connection provided by a local host. Yeah, that's one of the first instruments installed in a school. Just a picture example. And what happened by March 2024 is we were able to install only 15 receivers out of 20 planned, but mostly not because of lack of the equipment, but because of lack of the hosting organizations. Nevertheless, um, we almost got to our 20 full capacity of the plant network, and the red dots are indicating the location of our GNSS stations. So we got our results measured, and I will switch to the next slide to demonstrate that. And there is something still ongoing activities going, because we are planning to host a workshop among the teachers and some of the selected students to talk about GNSS technology and other opportunities in space sector in Canada this summer, later this summer. And we've been already working on the processing data and publishing our results. So before I go to a little bit about the technical details, I want to mention that we are the group of researchers, scientists, engineers, and such technicians behind the Canadian High Arctic Ionosphere Network that consists of 30 GNSS scintillations and TAC monitors that are effectively, these are dual frequency GNSS receivers, but scientific grade receivers. And installed in Canadian Arctic. And also we are operating 10 ionozones in Canada. Doing now, how the equipment was selected. Obviously, we have access to our chain network data, and we've been working with the equipment for the past more than 2 decades now. So we have a little bit of experience working with different equipment and opportunity to compare the low-cost receiver with the high-grade receivers. Those that were receivers we considered in Swift Pixie Multi, we started with those receivers, but unfortunately the company decided not to go any further, and it's no longer available. But the U-Blocks F9P is a brilliant piece of electronics that allows us to do the type of research we're interested in. And you can compare, obviously, a price point for every single uh, element. On this slide, I'm just showing you comparison of Novatel and a Pixie receiver installed in Qikiqtarjuaq. It's one of our northern sites in high latitudes. And on the left side, it's an uncalibrated TAC computed using dual frequency measurements, L1 and L2, with Novatel and Pixie, and a peak around the 515 UT shows a response, TAC response towards the polar patch going across this field of view of the instrument. And both receivers actually can cope with this type of gradient, which is like up to 10 tech units in a few minutes. And on the right side, a comparison of the difference between TAC computed low cost and high cost receivers is given with a standard deviation below 0.1 tech unit, or around 0.1 tech unit. A little bit about low latitudes as well. So we had a chance collaborating with ICTP, with people from developing countries, in particular low latitude countries. We were able to also compare performance of a U-Blocks receiver F9P with a Septentrio-Polar RX5 S, which is scintillation receiver, in Lagos, Nigeria. And here you can see already calibrated tech. Calibration technique was done by Bruno Nava and his team in this case. And if the first row will show a difference of like 1.6 tech units on average, and all the rest of the statistics, and with a couple of tech units standard deviation. And you see a very good correspondence one to another, but obviously with some minor sort of details, which can be improved. And here I should mention that for calibrated TEC, it's very important how you preprocess the data, how you choose the data. And as two receivers, the difference of a low-cost receiver U-Blocks F9P is that it doesn't track actually L2P signals. It only can track L2C in modern satellites, which is a little bit reduced in number of satellites in view second frequency. I'm talking about second frequency. So reduce this amount of TEC data we can obtain from the receiver, and thus affect the results of calibrated TEC. Nevertheless, if we do calibrate TEC with the same set of data from high-cost receiver and low-cost receiver, that's what you can have, you see at the bottom row of this slide. And then we go down to 0.2 tech units on average, and then just 1 tech unit standard deviation. A little bit more results just from high latitudes, and here just I like this plot because Novatel, which is also an aged receiver and a legacy receiver built by Van Derendonck, if it rings a bell for some of the people around, which is a part of chain network now, and a U-Blocks. And U-Blocks actually is performing better these days, just after 20 years of the technology improvement and reducing the cost. On this slide, I'm gonna skip this slide for sake of time. We just looked at how DCB of the receivers behave and compared Septentrio, Topcon, and U-Blocks. They are very similar with some minor differences. And going back to the response of ionospheric on TEC to the eclipse event we observed back in April 2024, you have here all 15 stations, low-cost stations in New Brunswick. They were operating, and they clearly see the response very clear and very nice what was expected. That's 3 days actually, one before the eclipse, one the day of eclipse in the middle, and a shadowed area is where shadow was passing at an altitude of 300 kilometers above New Brunswick. Here is again just some mapping. So first row represents data only from our stations, 15 stations, that you can clearly see the effect already. And if we involve more data from the US or Canada, like around the eclipse sort of affected territory, you can see more, like a better effect, obviously. But the more data we have, the better detail we can sort of try to study. And one last slide I want to show before switching to Bruno is that we were also lucky to have the Canon, or some of you may know of this storm as a Mother's Day storm in May 2024. And here is an example is given. The red line is a DST index, and the green and blue, these are two. One is a low-cost receiver, one is a high-cost septentrial receiver, TEC constructed using the two different instruments. And they have very well in line, and above all, they're like 20 kilometers one from each other. And with that, thank you so much. And Bruno, if you can take it over, please.
Okay, thank you. I will try to share my screen in that case.
Yeah, I should stop sharing.
Or maybe...
So you may note your questions. If you have a question, please note it down. After everything, we can ask.
Yeah, it's up to you, how you prefer.
Yeah, let's have Bruno, and then we'll have questions.
Okay, thank you, Anton, for introducing this part of the work. Again, also in my case, I will give a presentation that is a summary of some parts that I have already presented in other occasions. And since this is the first time in this kind of meeting, I didn't know exactly how to structure the presentation itself. I have included a little bit more material maybe than expected, but I will skip what is not relevant just in case the time doesn't allow. So the idea is to speak about the use of low-cost receiver to monitor the ionosphere, in particular total electron content. And indeed, in this slide, I wanted to remind the effects on GNSS of the ionosphere. And this is to say that we will concentrate our attention more on range errors, so group delays and phase advance that are causing the effect on the ionosphere, and we see total electron content exactly with this mean. This slide is to remember that we will not speak only about calibrated total electron content, but to compare receivers, we also take into account uncalibrated total electron content. About the use of low-cost receiver, as Anton has correctly anticipated before, we started to work with them at the time when low-cost dual-frequency GNSS receivers were even not available, or at least they were not so low-cost. And indeed, here we have an example of a single-frequency GNSS receiver that has been used back in 2017. But then we started to make our exercise, and we gained experience with multi-frequency, multi-constellation GNSS receiver. Some results have been published in collaboration with our colleagues, I would say, all over the world. And here I would like to emphasize that these kind of activities that are concentrated and focused on the comparison of low-cost GNSS receiver with high-grade GNSS receiver is going on, and relevant works have been done in terms of comparing total electron content, but also in terms of getting the possibility of detecting scintillation. In this case, I'm not an expert. I will not speak about this subject, but for completeness, I wanted to report that studies in this direction are also being carried out. About receiver comparisons. Well, I would like to start from an exercise, a test that has been done in collaboration also with our colleague Dinesh Mandanahar from University of Tokyo. In particular, he set up these 4 receivers, 2 high-cost and 2 low-cost receivers that have been connected to the same antenna, that I have to say it is a high-quality antenna through a splitter, in order to collect the data. In particular, data have been transformed to RINEX files, and starting from these files, we were able to analyze each of these receivers. First of all, we tried to analyze uncalibrated total electron content, and here I have only reported one example about phase tech, top left panel, for a given PRN for 2 receivers. In this case, we have the Polaris S5 as compared with the low-cost U-Blocks FP9 receiver. So we have a 1 PRN for which we compute uncalibrated tech. Same PRN for, as seen from 2 GNSS receiver, we report to the same average, and we see that the difference is very minimal. Indeed, in the central plot of the first line, we have the differences of the 2 uncalibrated tech that at the scale of the plot is almost 0. And on the right plot, we have a zoom of this tech difference from the same PRN as seen from 2 different receivers. And as we see, and as it has been anticipated by Anton, these differences are very, very small. In the bottom line, we have an example for which one receiver had a phase jump that is detected by the technique of differentiating the 2 uncalibrated tech, but where the outside, let's say from the phase jump or cycles dip, again, we have that the difference of the 2 tech corresponding to the same PRN for, as seen from 2 different receivers, and high cost and low cost receiver are definitely very, very small, indicating that already at this level, we can conclude that for TSC monitoring, the two kind of receiver are already sufficiently are sufficient. Then after that, we calibrated the total electron content using the same calibration technique applied to the 4 RINEX files data set corresponding to the 4 different receivers. And we obtained these results. I want to underline that the same calibration technique has been implemented. So the only difference is on the receivers. Here we have 2 receivers as compared for the 3 days that have been considered. The days are reported in the top part of the plot. And here we have the second pair of receiver, vertical total electron content calibrated from the other 2 receivers. And here we have, excuse me, in this case it is slant total electron content in colored lines, and the vertical total electron content is the black line. Here I have reported the vertical total electron content for the 4 receivers for the 3 days. I have overlapped them just to have by visual inspection, because here the statistics is, I would say, not convenient, is enough to have a visual inspection to understand that regardless of the kind of the receiver, we have the same estimate for the vertical total electron content for all the receivers, indicating that they are very useful to monitor total electron content. And in particular, here I would like to underline that this kind of receiver are already able, for example, to be used for model validation, for example, because here as a black line, I have overlapped and superposed the vertical total electron content as estimated by the Nequick model. And as we can see, there is a lot to do for the model in order to allow the model itself to match the vertical total electron content data. This has been an experiment done in very controlled environment. Tokyo is located in mid-low latitudes, but the question could be, what happens if we go towards low latitude, where we know that the ionosphere is much more challenging, not only to be modeled, not only to be measured, but also to be modeled? Well, we did some tests with low-cost and high-grade GNSS receivers in terms of uncalibrated total electron content comparisons. Here we have the relevant statistics for a test that has been done in Nigeria, Lagos. Correspondingly, here we have the same kind of test that has been done during geomagnetically disturbed period and quiet periods. As we see from the example reported in the plots, essentially the comparisons of the uncalibrated slant total electron content corresponding to low-cost and high-cost receiver are very similar, regardless if we are speaking about geomagnetically quiet or disturbed periods. So this is very much encouraging. And what about cycle sleep? We did also some tests to evaluate the receivers in terms of phase jumps and cycle sleep. And as expected, we have differences between low-cost and high-cost receivers. Again, the analysis has been done during geomagnetically disturbed and quiet periods. But at the end, when we try to calibrate total electron content, if we are able to perform a very good pre-processing of the data, we are able to have results from low-cost and high-cost receiver that are very well comparable. Here I have reported statistics and also the corresponding vertical total electron content in one case that we have analyzed, considering a U-blocks receiver, so a low-cost receiver, a septentrion receiver that is a high-grade receiver, that are in respectively in blue and in let's say a reddish color, as compared with total electron content as obtained by coded vertical total electron content maps, and again by the Nequick 2 model that in this case has been identified by the blue color. I will skip this slide because I understand that Anton reported this case to underline the importance of the pre-processing of the data when we calibrate the total electron content. And I will now briefly mention the ICTP network. So the ICTP experience in deploying low-cost GNSS receiver, acquiring the data and try to use them. Sorry. This is the current situation about the ICTP initiative that I would like to understand. It refers to the possibility to deploy low-cost GNSS receiver. I would like to mention that this initiative is on personal and voluntary basis, so there is not a budget for acquiring and deploying the receiver. Of course, we did it in collaboration with all the colleagues that are hosting the receiver that are prepared here at ICTP. And for this, I would like to particularly thank Anton for helping very much in this endeavor. Here we see in black, dark blue, the receiver that have already been implemented and installed, while in red, we have the receiver that are planned to be deployed in the next future. And when next future, of course, we don't know exactly what it means, but please let me take this opportunity to thank all the colleagues that have contributed so much in making possible this activity and this network. And I would like to acknowledge them here. And now I would like to give also to say a few words about what can be obtained when we deploy these receivers at low latitude. To do that, we have considered the period 29 April 2023, where specifically a geomagnetically disturbed period was present, and we tried to see how this in this period the ionosphere was seen by this low-cost receiver. Again, also trying to, when possible, compare low-cost and high-cost receivers. In this case, we have the results as obtained by the Abidjan low-cost receiver, that is a Pixie receiver, as compared to a high-end receiver in Yamoussoukro, that, by the way, is not co-located with Abidjan, but as we see, the results are very much in agreement. And we have this series of 7 days, essentially, that include the storm, and we see how the low-cost and high-cost receiver perform, corresponding one to each other. And since we have seen that they were very well performing, the low-cost receiver, we continue to analyze the data that we were able to collect from Lima in Peru, Accra in Ghana, then Sangli in India, and last but not least, also from Abuja in Nigeria. To further continue with our test, we rely on the low-cost receiver in Kikitarjuak, where there was an high-cost collocated with a low-cost receiver, and we were able to see this geomagnetically disturbed period, and so ionospheric storm effect in all the receiver that we were able to consider. And with this, I thank you for your attention. And of course, as usually say, if you would like, also in our case, to host a receiver, you might send an email to me, and we will try to see how we can continue these efforts when possible and when the possibilities will allow, of course. Thank you very much.
Thank you, Bruno. Thank you so much. This is really fantastic. Like we're happy to have you here this morning. It's a lot of work that you have been doing there, and we are looking forward to collaborate with you in the future when we start to implement CONGA. You're going to be very, very helpful. Yes. Thank you for all these interesting results. Do we have any questions? questions. I have a question. So Bruno, so those low-cost receivers, you have tested them in various weather conditions. So you show the case of solar eclipse, you show the case of geomagnetic storm. Can you confidently now say that this is a very good receivers that can be trusted, irrespective of any, don't need to fear, or do we need more statistics analysis to actually confidently say that?
I would say, okay, first of all, let's speak about total electron content, because this is mainly where we have tested the receiver, at least personally, and also, please, Anton, correct me if I'm wrong, but I would feel comfortable to say that low-cost GNSS receiver with a low-cost antenna of sufficient quality are, in my opinion, definitely suitable to monitor total electron content, the ionospheric total electron content, under different conditions. Of course, we have done tests. The results have been shown here. We have additional results that we can show. Of course, we have to continue with our investigations, but at the moment, I would say yes. I would say yes. Low-cost receiver are sufficient even to do research and science at the level that we have seen.
Excellent. Yeah, good to know. Good to know that. I think we have a question from Dr. Mohammed Ali. Mohammed, please go ahead.
Yeah, thank you very much. I am Dr. Mohammed Ali Garba from Nigeria. Sir, thank you, Mr. Bruno, for your presentation. I would like to know where the stations are. Is it located in Abuja or in Lagos? Thank you very much.
Lagos,
okay, I can try. The one that refers to the ICTP network, one is in Abuja, one in Ife, and one in Nsukka.
Interesting. So we have even 3 stations in Nigeria.
Yes, at the moment we try to let's say deploy them there. Of course, not all are functioning 100% all the time, but yes, this is what we are trying. These are the last 2, apart from the Abuja station, have been deployed very recently. And
Thank
here
you
I
very
think
much. Can I have contact of the person or anyone responsible? I would like to get connected with him, sir.
I would say for Nigeria, you mean?
Yes, yes, sir.
Definitely Professor Babatunde Rabiu. I have included, if I can, let me see if I can share the
Bruno,
map.
I guess he is here today with us, so he can.
I see his name,
himself.
so
Yes.
I think you can talk directly with him now, I would say.
Professor,
thank you very much.
Professor Babatunde,
okay.
Yeah, Professor Babatunde, yeah, you are free to say 1 or 2 things, Prof. Please.
Okay, thanks.
Yeah, always. Professor Babatunde is always.
You want me to say something?
Yes, please.
Yeah, I've listened to Dr. Ali or Mohammed Ali Garba. I don't know where are you speaking from. Are you from Nigeria?
Yes.
Yes, sir. I am speaking from Gombe State University in Nigeria, sir.
Gombe State University.
Yes, sir.
Okay.
Yeah.
That's the Gombe. Gombe, that's where we have Kashcheyev.
Yes, sir.
Okay. Okay. All right. No problem. You can drop your email address in the chat box, then I will reach out to you.
Okay, sir. I'm grateful. Thank you very much.
When I'm reaching out to you, I will copy some of the professors from the Federal University Kashcheyev so that you can also have a relationship with them.
Okay, but I am in Gombe State University, sir.
I know there's a difference between the state and the.
Yeah, okay. Thank you very much. Thank you very much.
Yeah.
All right. All right.
I was on accreditation team to Gombe State University a few years ago.
That's great. That's great.
Just drop your email address in the chat box. I will reach out to you.
All right. I think we might have met. Okay, thank you very much. I'm grateful.
Thank you. You're welcome.
Oh,
All right.
sorry, may I add one thing that I forgot
Okay.
to say that seems to be so, I would say, automatic, but maybe it's not. It is clear that all the colleagues that are hosting a receiver are also, and therefore are making the data available to the community, are also able to use the data, and it has to be, I would say, clear that if someone wants to contribute to a network like that, to an initiative like this, has to accept to share the data to the community. This is clear. Sorry if I underline that, but maybe sometimes it's better to make this, I would say, more clear, because I have heard in other occasions that in some cases the data are not made available. In our case, we definitely want that the data be shared
Excellent.
and made available.
Yeah, that's what I was going to ask you. My next question about data availability, and that is really, really good that you make the data publicly available.
Yeah, sorry. At the moment, for all the member of the initiative that are providing the data, but we are trying to understand how to do to make them publicly available for all the world. This has to be, we are just finalizing the setup of an SFTP server in order to collect the data and allow the downloading too. So please allow us a little bit more time in order to finalize all these actions.
And you must know that, I think you already know this already, that CEDA Madrigal website is also available to accept your data and make it public available. I have the vice president or director of IGS. They are also asking me to make CONGA data available to them, which is, this is what people have access to directly. So you might want to contact them to actually make it globally available for scientists and scientific studies.
Yeah, if I can insert a couple of words. So before the data from low latitude network is made available publicly, if there is anyone interested in assessing the quality of low-cost GNSS receivers, data from Eclipse and B network is actually available as a part of a chain network to everybody. And I guess MIT HiStack is already pulling the data from our servers. So if needed be, this low-cost receiver data can also be analyzed as well.
Yep. Perfect. So yeah, that's all good news. And yeah, do we have any questions? Feel free to suggest, and maybe next presenter will announce the next presenter. But if you want to present your projects and you want people to see what you are doing.
Okay.
Yeah.
Hello.
Yeah, go ahead, please.
Yeah,
Solomon.
yeah, Solomon from University of Jos.
Okay.
I want to know if anybody has used a low-cost data to explore for mineral. Is there any history of research like that? Anyone here can share with us. Let us see how we can replicate the study in Nigeria also. Thank you.
Sorry, I did not understand. Could you repeat, please?
I want to know if the low-cost data has been used for mineral exploration anywhere in the world.
Well, not to our
I don't
understanding
know.
right now. I'm not sure about that, but this is new experiment. Like I was asking Bruno, if we can totally have complete confidence in this data, low-cost data, and is with all his experiments, all his analysis, he said yes. So very soon we will start to see different exploration of low-cost data, receiver data in this field as well. like I said earlier, that we have people from different fields and that has showed interest. And CONGA is also going to be low-cost receivers. That's why I'm very, very interested in the performance of these low-cost receivers. So, and that is really, really good to know. And very soon, Dr. Solomon, we will start seeing, maybe you can even start that. If that is your field, you have data available to you right now by Dr. Bruno, who has been working on this and is confident that those data are guaranteed. They are very good for science. So you could start seeing this result from your side.
Okay, thank you. We'll consider it and work on it. Thank you.
Mm-hmm. Sure.
Thank you so much.
Sure. And any other contributions or questions for Bruno or Anton? Leslie, do you have something to add to this? Before we are almost at the top of the hour. I think we're over the top of the hour. So if you want to say one or two things, and also Yenka, if you want to say one or two things, and then we'll close this for this meeting.
No, I don't have anything particular to add today. Thank you again. Very nice presentations, and it's always exciting to see the work with this.
Hey. So if there's anything to add, we thank our speaker for giving a very nice presentation and helping us to understand more about low-cost receivers today. We have had several presentations on low-cost receivers. One of these is, I think, was invited by Yenka as well in the past from Japan by Dr. Dennis. That was really, really fantastic as well. So a lot of things going on with low-cost receivers. And that is a good news for CONGA network, because this is a very large network and we don't want to make mistakes. And so this will help us to know what is what and what is the right thing or what's right to low-cost receivers are in this case. So thank you all, and we will look forward to the 8th CONGA Meeting Series next month. And hopefully we'll announce the next speaker during the course of the week, and hopefully we'll see all of you again next month. Thank you all.
Thank you very much, Paulo, for your kindness.
Thank you.
Thank you so much.
Yeah.
Thank you. Bye-bye.
Thank you.
Thank you.
Bye.
Yeah.
Thanks. Bye-bye.
Thank you. Thank you. Have a good afternoon.
Thank you.
Thank you.
Yeah.
Thank you, sir.
Thank you. Yeah.
Thanks all.
Thank you. Yeah.